Okay. Hello and good evening. Welcome to this evening, this fine Tuesday's week 5 workshop for Freight Frenzy. Tonight's workshop is going to be on programming with Android Studios from our Rice alumni first chapter. Um, Week 1 we went over building robot vendor kits and the pros and cons. Week 2 we went over build a robot, that we had a team actually demonstrate and show us different ideas to actually build robots and different kits to use instead of just one standard kit, and different ways to actually try and compete and be competitive for this year's competition. Week 3, we had the engineering notebook versus the portfolio and the goods and the bads and the best things for judging. And then week 4, what was week 4? Oh, it's week 4, not week 5. My fault. I forgot we're 1 week off. But I will now hand it over to Rice.
No, week 4 what's the we did
Awesome. So yeah, this week we're going to be giving a general presentation on kind of getting Android Studio set up, as well as kind of some basic programs that you can write using Java. So I'm Ethan Peck. I'm a sophomore here at Rice, majoring in electrical engineering.
And I'm Bryant Cassidy. I'm also a sophomore at Rice University. I'm majoring in computer science, and I did First Tech Challenge for 5 years on team FTC 9879-1.
So I think first Brian is going to start, and then after a little bit, we'll switch back and I'll kind of go through more parts of the webinar.
So the first thing to be able to program on Android Studio for FTC is you need Android Studio. So to download Android Studio, you need to go to this link that's on the screen, and I'm also sending it in the chat now. If anyone here is currently downloading Android Studio, you can let us know, or if you already have it. I don't really want to leave anyone behind, and we're happy to wait for it to download if it takes a few minutes. So if you could just let us know what your status is, maybe in the chat, or unmute yourself. I am not seeing anything, so I think I'm going to assume for now we're good. Anyone watching this later, feel free to pause the video until the download's finished. You can go ahead, Ethan. Oh, yeah, there we go. Sorry. So you're also going to need the FTC library, which you can download as a zip file from GitHub. I will also send that link into the chat now. After you download this, you're going to see it in Windows, kind of like the picture on the left. And then you're going to want to click Extract All. Ethan, could you hover over that button? The Extract All button. Oh, yep, just like Ethan's showing right now. And then you're going to want to click Extract All. You'll want to choose the folder that you want all of your FTC files to be stored in. In this case, I just have it on my desktop. And then you'll click the Extract button at the bottom right. Yep, go ahead. And then you'll also want to finish installing Android Studio. So after you download, you'll want to run the .exe file, and then you're going to click Next until you get to the Finish button, and that should install everything. Again, if you're watching this later, feel free to pause and go through these steps, and then come back to the video once you've got it installed. Once you have Android Studio, there's a few settings that we're going to make sure that will help our robots actually communicate with the computer. So the first thing you're going to want to do is click on this configure button in the bottom of Android Studio, choose settings, and then go to instant run. And on instant run, you're going to want to enable the checkbox at the top there. And this will make it so when you download a program to your phone, it will automatically go to the FTC app and boot it up for you. Yeah, so if you want to continue. The next thing you'll want to do is you'll want to import the project that we actually just downloaded. So you'll see this screen on Android Studio and you will click Import Project. And then you're going to choose the same location that you extracted the file. In this case, it was named Skystone. Obviously this year it will be newer, but this is what holds all of the FTC robot controller and the team code. And you should actually see a little Android Studio icon on the right side in your file structure, which tells you that it's an Android Studio project and can be imported. And then you'll just click OK when you're done with that. The next thing you'll need to do is you will want to prepare your phone to be able to download the robot code, or if you're using a driver hub, your driver hub should already be set up and you won't have to do this. But if you are using a phone, you'll want to click the About Phone button. I think it's 7 times, maybe it's 10 times, until the developer options pop up. If you just keep clicking About Phone, that will eventually happen. And then once you're in the developer options, you're going to want to turn the developer options on, enable USB debugging, and then always allow it for this computer. And this is going to allow your computer to download code directly to your phone. So next we're going to talk about a little bit about the file structure of the FTC library. So there's 2 main folders. The first one's called FTC Robot Controller, and the second one is called Team Code. FTC Robot Controller, FTC Robot Controller stores all of the sample code and all of the libraries that you might need when programming a robot. So if you ever need to look at a sample, I would go into FTC Robot Controller, but in general, you should never be creating anything inside FTC Robot Controller. Where you're going to be creating files is inside this team code folder, and inside team code, you'll go to Java, and then you'll go to this org.firstinspires.ftc.teamcode, and this is where you're actually going to create your Java files. Otherwise, there are a few other folders there. In general, you don't need to worry about those. Eventually, if you get to some pretty advanced stuff, you may be editing the Gradle a little bit, but at least at this point, you don't need to worry about that. There is one other setting that we want to enable now that we're actually in Android Studio, and that's called auto import. And what this is going to do is it's going to make it so any libraries that you're using will automatically be imported and downloaded into Android Studio. And so you're just going to go into settings, go into editor, general, and then choose auto import. And you'll want to make sure all of these boxes are checked. So the next thing we're going to do is talk a little bit how an FTC program works. And I believe I'm going to pass it off to Ethan for this.
Okay, yeah. So now that we've kind of walked through the general steps to just get Android Studio up and running, we're going to walk through the basics of how you write code in Java. So one of the files that you'll probably see and that we'll have a link to later as well is this kind of example autonomous program here. And for those of you that don't know, an autonomous program is the program that runs at the beginning of a game for your and the period before driver controlled. So here's our example program here that we're going to kind of work with in just a moment. And so here you see we have this comment. That's what those 2 slashes mean, where we're going to put declarations. And so in this case, declarations are things like we're going to say what motors we're using or sensors, things like that. And then initialization, which is this part here, is where we're going to actually assign those motors to the motors connected to our robot. And then we have this wait for start, which essentially is just, as the name implies, waiting until you start your autonomous period. And then actions here are just all the code that you're going to write to actually control your robot and all those motors and sensors and things that you've just worked with. So I'm going to work on opening Android Studio quickly and open the project. And in the meantime, driver controlled is very similar. You'll notice that instead of at the top here for autonomous, where it says @autonomous, now it says at teleop, and it also has this thing here that says extends op mode. Most of the time you don't have to worry about writing this because you'll probably have this shell file or something. So it's a little bit different this time. You still have the declaration in the same spot. This again is where your motors and sensors, you're going to say how many of each different type you're using. But so now instead of having just one run function here, you have two. You have an initialization, which is just called init, and then you have a loop, which is going to be everything that runs after your initialization over and over again. So things like checking if you're pressing a button on a controller and you want your robot to move. So in init, obviously, as the name kind of implies, you're going to have your initialization where you're setting up all of your motors and sensors. And then this loop part here, this is where you're going to be doing all the cool things like, reading in driver inputs and moving your robot and making it do different cool things. So for an example of declaration, which is this part that we talked about going kind of at the top here in both autonomous and driver controlled. So in this example, we're setting up 4 different motors. And so this would be like if you had a robot, 4 wheels, each wheel connected to a motor. Here we have the left front motor, then the right front, then the left back, and the right back. And so essentially, this is just saying we're going to have 4 motors total, and then you can give this name. You can make this name anything that you would like it to be. So you don't have to call it left front or right front, but we just chose a name that was very descriptive. So following your declaration, you're going to have to do initialization next, which is what you'll find here in this init section in our driver controlled, and then here at the start of our run function here. So initialization is essentially where you're going to actually assign your motors or your sensors or whatever things you're working with to the actual physical parts that you're using on your robot that are connected to your control hub. So in this case, we're saying that left front, which is this motor that we talked about earlier, this DC motor, we're setting that equal to this thing that might look a little confusing at first. It says hardware map.dcmotor.getlf. So basically what this is saying is we're using the hardware map, and then we're accessing a DC motor on the robot, and then .get. And in parentheses, this is going to be what you name your motor on the app in the configuration for your robot. So in our case, it's just named LF, but you could name it anything. You could name it left front. You could name it motor 1, motor 2, motor 3, whatever. Anything that you think is most descriptive for your team. And so you'll see that we repeat this process for each of the other motors following this left front one. So for the right front, we use the same hardware map and then DC motor to get the right front, or RF as we called it in our configuration, and then repeat for left back and right back. And so that's just a general overview of how you actually assign those. Then you also have this option here to set modes. And so this is essentially saying if you're going to run your motor with encoder counts or not, which at this point isn't super important what specifically those mean. We'll get more in depth with that in a bit. But so yeah, that's just a general overview of the initialization part. So now that you have your motors set up, you can actually set them to move and things. And this is what we would see in our either loop part for driver controlled or in our autonomous part for running the actual mode. So here, this is exactly what a line of code would look like that's going to set your motor's power. This can be anywhere from 0 being off and 1 being on. And so here's just a little video of, it might be a little tough to see, but we've set power to 0.25 and you can see that it's spinning around. So to kind of explain this, motor 1 is the name. So like, for instance, if we were talking about the motors we had from before, we could do left front or right front, and then we could do left front dot set power, which is essentially the action we're taking. And then this value here in these parentheses, which is essentially where you're going to put your power that you're providing to the motor. So anywhere from 0 to 1. So let me see. So here's another example of a different type of motor that we haven't specifically gone through the initialization of yet, but a servo motor doesn't actually, you can't provide it a power, but you can set it to an individual position anywhere from 0 to 1. And so in this case, we're setting this position to 0.5. So here's a little video of that. It might be a little tough to see, but you can see that it spins to a certain position. So, and this is very similar. We use the name that we assigned it earlier. This could be anything that you set it to. And then we use .set position to say that's the action we want to take. And then in these parentheses, this is where we actually put the value. So let me move to the next slide. So here, what we need to do is you probably heard me mention things about the configuration and things like that. So we'll actually need to set up your phone. You'll actually need to set up your phone so that it's connecting to the robot and that you can upload code and things like that. So with the FTC app open, you're going to navigate to settings, and under network configuration, you're going to want to connect with your robot controller. And so then you'll have this thing for Wi-Fi devices, and you're going to want to select whichever one shows up other than none, essentially. And so you'll get this invitation to connect, and you'll want to accept that. So in addition to that, you have to do control system setup for the control hub, which again is very similar. The layout is quite similar. You're going to have this little settings, 3 dots in the top right corner of the window. So you're going to click that and go to settings. And in this case, you're going to pair it with a robot controller. And it's pretty similar. You'll go to Wi-Fi settings, and you'll have some sort of password set for this. The default password should typically just be password for when you're connecting to this network. And then once you've filled that in, you should hopefully see this robot connected right here, and maybe some information about like the battery attached to it and things like that. So following this, now we can talk about that configuration that we were mentioning. So again, you're going to click this 3 little dots icon in the top right. You're going to click configure robot. And if this is your first time setting it up, you'll see no configurations found. And so what you'll do from here is click the new button to create a new configuration. And you're going to scan to look for attached devices. So things attached to your control hub, things like that. And you'll have this, hopefully have this expansion hub if you're using an expansion hub. And then you can just select that. So now that we've kind of gone through how you set up the configuration, now we can go through how you actually give the individual names. So in this case, we've selected it, and we have this option to choose expansion hub 2. And then in our instance, we're going to be adding our motors like we talked about earlier. So just some basic DC motors. So here for 0, 1, 2, and 3, you're going to give it whatever name you'd like to give it. And in this case, the 4 that we used were LF, LB, RF, and RB. So again, you can set those names to whatever you'd like them to in this part of the app, just whatever you think is the most descriptive for your situation. So now that we've kind of done a very basic walkthrough, I'm going to open Android Studio up and actually walk you through creating a program. So give me 1 second, and I will open that up. Can everyone see that? Okay.
Yes.
So I'm going to be opening the project that we downloaded earlier, which is essentially the FTC files where we're going to be putting our team code. So let's see here. I'll need. Let's see. There we go. And then it should be FTC color master. There we go. Okay. So fingers crossed, everything loads correctly. Yep. You should see this probably when you first open it on this README. And it's going to take a second to load while it loads everything in if this is your first time opening the project. And so let's see here. Still working on it. My computer is a little bit slow currently. Okay. Still is taking a little bit. So in the meantime, I'll take this time to say that we actually have a link to where all of the files that we've talked about will be. You'll want to look in the session 1 folder of this GitHub link I'm about to send in the chat. And this has things like our example autonomous program shell, as well as some basic driving forward and driver controlled examples. So there we go. Looks like everything's opened up. We have this team code folder, and then I go into Java, and then this team code section here. And so what we're going to be doing is creating a new, you'll be right clicking and selecting new Java class, and you can name it whatever you'd like. But the important thing is whatever you name it, that needs to be the name of your class. So I'm going to call it autonomous example in this case. And what I'm going to do is from the GitHub that I had from earlier, the link that I sent in the chat, I'm going to put in our example file here. So this is the one that essentially has everything, all the shell stuff set up, except for we have to do our declaration and initialization and actions. So for this example, what I'm going to be starting with is just a basic program to make our robot move forward. So what we first need to do is in our declaration, we need to set up a handful of DC motors. So we're going to need 4, 1 for each motor on a robot. So in this case, you'll see this thing pop up here. This is just autocomplete. You can select DC motor. And it'll fill that in for you, and it'll also make sure that you have it added up here. So would recommend using that. And so then we're going to give it a name. So like I talked about before, we have this left front motor, and then we're going to repeat this 3 more times for each of the other motors. So we've got right front, we've got left back, and we've also got right back. So these are our 4 motors. They're they're declared, and we've given them some descriptive names. So now what we need to do is actually initialize these. So in the start of our run function here, I'm going to initialize each of these using the name, and then saying that it's equal to our hardware map, like we mentioned before, and then we're going to be getting a DC motor, and then getting it by the actual device name, which in this case, in our example, we used LF. And that's just, again, from your configuration on the actual phone app. So then I'm going to repeat the same thing for each of the other ones. Just a second. And then, and then finally, we've got right back. There we go. So now we've initialized each of our motors. In addition, we can do some of this setting mode like we talked about before. So in this case, we'll do back.set mode. And we're going to be accessing the run modes, which are essentially just to deal with the encoders. And stopping and resetting encoder is just saying you're resetting your motor and you're about to use it again and you want to reset the encoder count and things like that. So following that, we're also going to want to set our motor to run without the encoder. We just want it to run on a power. We don't want it to run after a certain amount of encoder counts or anything like that. So we're going to run it without encoder. So following this, we have our wait for start from before, which is essentially saying we're going to initialize all this stuff, and then it's going to wait until you press the play button on your phone. So finally, now we can actually get to making our robot do some cool things, which in this case is just making it drive forward. So the first thing that you're probably going to want to use to get it to drive in a straight line for a certain time is use wow. And then we're going to access the amount of encoder counts that have happened with the left back motor so that we can get a general idea of how far our motor has gone. And we're going to do .get current position. And this is going to give us a number that goes up from 0 so that we know in general how far our robot has gone. And so in this case, we can pick a number somewhere around like 2000 before we actually stop the robot. So this wow is just saying that essentially, while the amount of encoder counts is less than 2000, then we're going to want to run some sort of actions inside of these brackets here. And so we'll start kind of writing some of those actions here. And so in this case, we're going to want to set our motor's power so that it can keep going forward. And so because we have 4 motors, we're going to need to set the power. We're going to need to set the power on all 4. And so an important thing to note too is that because some of the motors are on the left and some of the motors are on the right, some of them will actually have a negative power, which means that they're spinning in the opposite direction. So that way we can make sure the robot actually moves forward instead of just turning or staying still. So in this case, we're going to do left front set power, and we can set this to 0.5. And we can also do the same for our left back. And so when I set this 0.5, then we also have right front power. And we're going to set this to negative 0.5 because it's on the right side. And then we're also going to want to do this on right back as well. And we're going to set this to negative 0.5 as well. So this is putting our motor at half speed on each side, and they're all going to be spinning in the same direction so that our robot moves forward for 2000 encoder counts, which encoder counts aren't exactly, it's probably easier to think of things in terms of distances, and encoder counts is just something kind of internal to the motor. So it'll just go forward for a certain distance, and typically you would want to play around with this value here to get it to go forward the amount that you want it to. So now we have this section here that's just saying, okay, while the motor encoder counts is less than 2000, we're going to keep moving forward. But once we're done moving that way, we're going to want to reset all our motors back to not have any power to them so that essentially we can make the robot stop. So in this case, it's going to look very similar to before, except instead of setting our power to 0.5 or negative 0.5, we're going to set each of them to 0. So you'll see I'll do that for each of these. Set that to 0, and right front, set that to 0, and then also right back, set power to 0. So this is just kind of a general example of an autonomous program. If we were to run this on a robot currently, we would run it, it would initialize all the motors, and then as soon as we press start, it would drive forward for a certain distance and then finally stop. So if you want to see this example later on for you to reference, it's going to be on that same link I sent in the chat, which you can go to. And if you go to session 1 and look for driveforward.java, that's going to be this program essentially. So you can paste that in and run it on your robot and get it to drive forward if you'd like to. So now that we've kind of talked a little bit about an autonomous program, I can show you a little video of what this would look like too. 1 second. Let me share this. Okay. Can everyone see that? Hopefully.
Yes.
Okay, cool. So yeah, very basic program. It's going to drive forward, and then it's going to stop as soon as it reaches 2000 encoder counts. So very simple, but the basis for a lot of different cool things that you can do. So now I'm going to switch back to Android Studio. One moment. Okay. All right. So now what we're going to do from here is actually create a driver controlled program. So a driver controlled program, as the name implies, is after the autonomous part of a match, and it's when you're actually going to be using your controller to move around your robot. So things are going to get a little bit more involved in this case, because we're going to have to do some stuff with actually accessing the controller and things like that. So let's see here. I'm going to create a new class here, and I'm going to call it driver controlled example. And I'm going to take the example file that we had from earlier. It's also on the GitHub. I'm going to paste this in. And now what we're going to do is just a basic driving program. So what we're going to be creating is something called tank drive, where essentially each joystick on the controller pushing it forward controls the motors on one side, and then the right does the right side. And so if you push both forward at the same time, then it moves the robot forward. If you do both backwards, backwards. And then if you do one at a time or in opposite directions, the robot will turn on the spot. So what we're going to do first we need to initialize things. And I'm going to put these in here because essentially, let's see. Okay. What we need to do is have our 4 motors again. So this is going to look just like before. You'll see that we have the same 4 motors that we had over here in our autonomous program, our left front, left back, right back motors. And here we have our initialization, which just like in the autonomous program, how we have this kind of initialization stuff is going to be the same thing here. But so in addition to having our motors, we're also going to actually want to set some numbers up that we can use to store the positions of our left and right joystick on our controller, so that we basically know how far it's been pushed forward and if we need to move the robot at that time or not. So what we're going to do is create this thing called a double. And a double is just a decimal number, like you've probably seen a bunch, like 5.5 is a double, or negative 0.1, things like that. And so what we're going to have is 2 of these. We're going to have one called left joystick, and we're going to set this equal to 0. And then we're going to have another one called a right joystick, and we're also going to set this equal to 0. So essentially, these 2 joysticks or these 2 numbers are going to represent how far forwards or how far backwards we have the joystick on each side of the controller. So now that we have this all set up, we're going to go into our initialization. And just like last time, we're going to set our motors up the exact same way. So in this case, we've got the left front and left back and right back, and we're setting those all with the configuration names that we had from before. So now that we've done that, we're going to actually start doing some of the cool stuff in our loop. And the one thing that's going to be a little bit different this time is we're going to be accessing the gamepad. And so the first thing that we want to do is essentially we want to update the value that we're storing in this number called the left joystick. And we're going to update it to whatever the position is of the actual joystick on the gamepad. So in this case, what we're going to do is set it equal to gamepad. And you'll see here that we have gamepad 1, gamepad 2. In this case, we're only going to be dealing with just one gamepad. And so in this case, we have the option for a left stick, as well as a bunch of different buttons. And in this case, what we're going to want to do is the left stick y-axis, because the y-axis is the up and down part of the joystick. So in this case, what this is saying is, what is the position of this left joystick on the y-axis? And that's going to be a number from -1 to 1. And whatever it is, we're going to assign that value to this variable decimal number that we talked about before, left joystick. So we're going to do the same thing for the right joystick. And in this case, it's going to look very similar, but instead of getting the y-axis on the left stick, we're going to get it from the right stick. So this is doing the same thing. It's just reading from the right joystick and saving it to our variable that we set up here. So now that we have these two numbers representing the positions of the joysticks, we can actually use these to modify the power in each of our motors. So what we're going to want to do in this case is essentially set the power of our motor to be equal to these values that we've saved. And so in this case, remember that the one side has to be negative and one side of your robot has to be positive so that your robot doesn't just stay stationary if you're trying to go forward. So in this case, we're going to say that we're going to set the power equal to negative left joystick. So we're setting the power to be whatever value we got from our gamepad and saved to this variable left joystick. So we're going to repeat the same thing for our left back motor. And when we set this power, we're also going to set it to negative left joystick. And now, finally, we're going to do the same for our right front and back motors. And we're just going to set this equal to the right joystick value instead of the negative value. That way, again, because the motors are on different sides so that they're spinning in the same direction when you would expect them to. So I'm going to set the power here. And after that, we have everything we need for you to have a very basic program that essentially you can push both sticks forward to move forward, both back to move backwards. And then if you push one up or down, it'll turn one direction or the other, depending on which one you have. So now what I'm going to do is show you a very quick video of an example of this program. So let me stop sharing real quick. And let me share this. And then I'm going to full screen it and show you this video very quickly. So you'll see push both forwards, it went forwards, both backwards, it went the other way. And you can turn by moving them in opposite directions or by just moving one side. So yeah, again, this file will be in the example files that we sent in that GitHub link. So if you want to upload these to your robot and maybe play around with them some to get kind of used to the environment, then go ahead. We also have some other example profiles from webinars that we've done in the past. If you want to look through some of those too, feel free to, but we haven't really gone too in depth with some of the concepts that those ones cover. So I think that just about wraps everything up for this webinar. So we've kind of talked about Android Studio and how you would set that up and get all the project files in there. And then also some basic autonomous and driver controlled programs. Yeah, we really appreciate you guys watching this. And if any of you ever have any questions, feel free to email our group, our FIRST alumni organization. Our email is first@rice.edu. And we'll be sure to get back to you guys to give any help that we can. So thank you.
Nice presentation.
Did you?
Can you hear me? Can you hear me now? Okay, there we go. It's not echoing. Sorry, technical difficulties in this house. Thanks for the presentation. It was a very good, informative presentation. The walkthrough was great. Are there any questions from our audience for right now? Because I do have a question that I don't know. You can probably answer it because I always have the same issue every once in a while. Whenever I'm creating multiple op modes, every once in a while it would ask me, it would say that you need to register this op mode into the index, and I usually end up finding it and doing that, but then I don't ever understand why it sometimes tells me that, because sometimes it tells me to do it in team code, but other times it might tell me to do it in the regular FTC App Master.
Okay. Do you mean like an Android Studio or?
Yeah, Android Studio.
Okay. That's actually a good question. I'm not 100% sure if I've ran into that issue. So are you talking about here? I'll share my screen quickly. This part here, where like the when you
it'll tell you to register the public class. Yeah.
Okay. By register the public class. So typically Android Studio should handle that for you. It might have something to do with the name of your class not matching the saved class. And it also could have something to do with maybe not extending the right mode. So like autonomous, you'll extend this linear op mode, and driver controlled is just regular op mode. But honestly, yeah, I'm not 100% certain. Those are just kind of some general guesses, I guess, that I have. But yeah, I'm not 100% sure.
There was that one, and then the other question. I have one more. The Gradle updates. Every once in a while, there's like one or two teams that I usually end up dealing with that have the same error, where after downloading Android Studios, it says to do a Gradle update, and then usually either I tell them yes or I tell them no, depending on the computer, because sometimes it goes through smoothly, and it'll download in like maybe 30 minutes. Other times it'll take like 6 hours.
Okay, I see.
And usually I'll just go and update it myself in the SDK or in the the JDK myself, just so that way I can isolate what I actually am going to be using. But I just want to know if you might know what that error is.
Yeah. So so Gradle is like a package manager, and it's usually pretty important because a lot of the FTC stuff, all these build files here are essentially how it's going to be, as the name implies, building your like code when you're uploading it and things like that. So I definitely recommend, if you can, updating it on computers. And I get, sometimes it's not particularly ideal when like the download takes like 6 hours. So I would say if you can, definitely update it, because it can definitely avoid some of those issues. But it also probably won't be too big of an issue, because I don't think that FTC is particularly going to be using any features that come with like new updates of Gradle. So if you can, yes, but if not, it probably shouldn't be a big issue unless you just can't upload things to your robot, in which case then you'll probably have to go back and go through and update it.
Okay, cool. Thanks for the answer. And last and final question. This is just a funny question to me. Do you usually keep it in white background, or do you keep it in is it Dracula, the black black background? I usually keep it in black just because.
Yeah, I normally do as well. I actually didn't have Android Studio installed on this computer until recently when we were doing some other webinars, and I just haven't changed it yet, but I'm almost always using IDEs in dark mode.
Same.
Yeah.
Okay, well, thank you so much for do we have any updates on the competition for our region? Brian will be sending out an email on Thursday on an update on the competition things and other information from him and Miss Sharon Sledge. But besides that, I have no information to give you right now. Thank you for joining our presentation. Thank you to the alumni group for doing this presentation. I know you have another one. Is it week 7 or 8? Connecting the STEM industries. I
think
I have to check my list, but I know you have one more that y'all said y'all were willing to do for us.
Yeah, I believe
thank
so.
you. And if there aren't any final questions, because we were pushing 5 minutes to 7 o'clock, and this game starts at 7:15. 7:09. I was close. If there's no final questions, I'd like to say thank you to everybody. Thank you one more time to Rice, the alumni chapter for first, and have a good night and good evening. See y'all next Tuesday. I'm gonna stop recording.